Now, in this lecture series, we shall learn that how we can design the steel structural pipe rack. Now, pipe racks are the structures that are usually used to take the pipes from one location to another in very heavy industrial steel projects. So, the purpose, as I said, let us say if we have to transfer the pipe from one point to another, so we have to build this kind of pipe rack. Now the loading which are like happening on this particular pipe rack, that may be, we can say, the dead load of the pipes, the live load. Let us say we usually do have a maintenance platform also on the top. We do have a wind load that is basically in majority of the cases governing the design also of these kind of pipe rack structures, and it can be seismic load also. So similarly, this is the actual pictures. Like here you can see that they have made a transition here for this particular pipe rack, and like it depends on the project that you are handling. The pipe racks may be small also, and it may be very heavy also, and it may be a single tier also and multiple tiers also. Tier means the levels here. So here you can see that, let us say if we are talking about this particular pipe rack, we do have approximately 1, 2, and 3 number of levels in which we do have multiple, we can say, number of pipes installed. Now, the loading or the diameter of these pipes, that is usually governed by the piping engineer. The one that is designing these kind of heavy industrial, we can say, pipes, or the process engineers, which determine what exactly shall be the medium that shall be flowing through these particular pipes. Now, this is basically the insulation that is installed on the top, because ultimately we may have, we can say, hot liquid also, or hot steam also, or very high, we can say, very chilled water also, or very cold water also. So it all depends upon the piping requirements, and basically the purpose of the piping engineer is to give us these loadings itself. So let us say at this particular point, they are anchoring this particular pipe to this particular beam. So there shall be a lot of horizontal load also on this particular beam. And similarly, if there is a transition that is happening here at this particular location, we may have a push and pull loading also. Push and pull loading means that the pipe itself shall either push this particular steel structure or pull the particular steel structure depending on the loading requirements. So, although this kind of arrangement, it is a very simple arrangement, and it may be used only for a single pipe rack. But if we are, having a multiple, we can say, series of pipe rack, let us say this particular arrangement here, we do need to have a very sophisticated steel structure and appropriately designed steel structure, so that we can accordingly design the arrangement. So we can see some other excellent pictures also of the steel structures. So here we can see that how they are supporting this particular, we can say, vessel, and that support is made with the help of these very, we can say, small structural steel beams, but on the condition that they have provided the bracing, this kind of bracing along the complete length on all the four sides. So whatever vertical load is coming, that can be taken by the steel beam, and whatever lateral load is coming, that can be transferred by this particular bracing arrangement. Similarly, that is like the basic structure. If we are making a structure that is very tall, or we can say aspect ratio is very high, in that case we do need to provide this kind of bracing arrangement. Only and only then it shall be stable. Otherwise, if we keep on making a structure without any this particular bracing arrangement, it shall be, we can say, very uh, weak, and it shall be very difficult also to design. So this is a simple, we can say, basic arrangement of the pipe racks. So this kind of pipe rack is also there, but we shall be focusing on so first of all on a very simple pipe rack, but that forms the majority of the cases of the, we can say, arrangement. So here also you can see this is a single line diagram in the structural analysis model. So this has been done in the StatPro software, which is quite widely used in Middle East, India, and US also. But in Australia space, gas is mostly used, or ETABS is mostly used. So we shall be designing first of all on the ETAB software itself, that how we can design the steel pipe racks. Here also you can see one more picture. So basically here you can see that the span here is very long, because there must be a road below this particular, we can say, pipe rack. So that is why, we can see this kind of arrangement here. And you can see some other pictures also. So here we can see that this is the 3D model, and this is basically the L-shaped pipe rack. Here you can see that it is going first of all straight and then on the right. So in this part, kind of, L-shaped pipe rack, either we isolate these two pipe racks. So here you can see these two columns, so they have isolated, but otherwise they have isolated structure itself. But if we want to join this particular structure arrangement, we do need to provide a very strong cross bracing here, because there is a lot of horizontal forces that are traveling in this particular L-shaped junction. So I hope the picture is clear to you, that what exactly are the different kinds of pipe rack. And this is also another excellent picture here. So either the pipe racks are made in steel. Here you can see this is the simple steel pipe rack, or they are made in RCC also. That is in places where the corrosion is an issue, and the loading is also quite high, and the speed itself is required. So in that case, they make these kind of RCC, precast RCC beams, and then install on the site. The third type is the sleeper type pipe rack. So that is used when the level of the pipe is like 600 mm above the ground or 900 mm above the ground. So in that case, this is the third kind of pipe rack. And this is also another excellent picture showing the 3D model of the, we can say, the pipe rack. And if we want to see some other drawings also, so this is how the drawing is usually prepared of the steel pipe rack. So here you can see that they have made the process structure also on the top, but in our case it is not that heavy. So we shall try to restrict our understanding on the simple pipe rack. Yeah, this is also another excellent picture. You do need to understand here that usually structural engineers do provide a lot of bracing in these pipe racks. So here you can see that they have provided two columns here, a moment frame here on this level and this level, and a bracing here. So here also he or she has provided the bracing, the moment frame, and this is basically the shear frame that is from this direction to this direction. And to attain the height, they have provided the elevation bracing also. And because there is a lot of lateral thrust also, that is thrust in the plan itself. That is, let us say if we are fixing this pipe rack here, it may be pushing, or as I said, there may be push-pull load on this particular steel beam. So in that case, that is why we can see this plan bracing also, and that is like very important when we are designing the steel structures. So we shall be, start to start designing the steel structure itself in the, first of all, in the ETABS software. So we can open the ETABS and we can click on the new model, and we can import the earlier model that we have made in the, like, for the photo bridge. So we can simply import the settings of the photo bridge that we have already worked on for a very finalizing all the load combinations. So that is why it is recommended that we can proceed with that. So as of now, we can proceed with uniform grid spacing. And this, first of all, we can proceed with the blank itself. We can left click on OK. It is better that we follow the process as per the understanding. So we can go to the define and material properties. And this we have already added the grade 300E and thickness between 11 to 17 also, thickness between less than 8 also. So that is already there. In this we can add AS3679.1, and in this we can add thickness less than 11 also. And additionally, although we might not be requiring that, but if there are like very large spans, in that case we can add thickness greater than 17 also. So in our case, like, it is not required, but we can add it also. So we can again left click on OK, and then after that we can go to the section properties and frame section, and we can check what are the sections that are there in our database. So we do have 310, 360, 410. We can add heavier structural steel sections also. So we can left click on import new properties. In this, we can left click on import new properties, and in here we do need to click on the I shape section. In this, we can add we already have 310, 360, and 410. We do need to filter the text with UB, and in this we can add 200 UB. We can press Ctrl key option on a keyboard. After that, we can add 250 UB 25.7. After that, we already have added 310. We already have 360. We already have 410 also. So after that, we can add 460 and 530 and 610 also. So why I select the minimum structural steel weight is because if we compare the strength of the steel section, let us say if we compare the strength of uh, 410 UB 59.7. So if we are comparing that with 360 UB 56.7, so there's a difference only of 3 kg per running meter between 360 and 410, but the strength of 410 must be very high as compared to 360. So always it is recommended that we do proceed with the minimum structural steel section weight with the particular depth so that we have a maximum performance to weight ratio. We can left click on OK. So now we have all the range of the sections available. We do have 200, 250, 310, 360, 410, 460, 530, and 610. In here, we can delete the box sections. We do not need that in our case. So we can click on delete multiple properties, and we can simply select all the box section here and delete selected frame sections. Because in modeling, our model needs to be clean and accessible at all stages. Only keep those things that are really required. Delete all the remaining sections. So this is required, and after that we can left click on again import new properties. In here we can select C channel sections. Yeah, one more thing. In the case of 610 UB101, we do have a thickness of 14 and web of 10.6. And in here we have selected 11 to 17. So that is accessible because 10.6 and 11, that is rounded off. But in the case where we do have 530 UB 82, in that case, our web thickness is 9.6, flange thickness is 13.2. So in that case also it is okay. If we are having 460 UB 67.1, in that case again we do have 8.5 and 12.7, so it is selected between 11 to 17, so that is also okay. 410 UB 59.7. In that case, we do have 7.8 and 12.8, again between 11 to 17. So that is also okay. Similarly, we do need to check, otherwise the yield strength parameters may be selected wrong. So in here it is flange thickness is 9.7, web thickness is 6.9. So we don't need to go between 11 to 17. We do need to select less than 11 in that case. So this is also okay. And for 310 UB32, we do have 8 and 5.5, that is thickness less than 11 Similarly, 250 and 200, that may also be corrected. That is 8 and 5. So in here we can select thickness less than 11 After that we can select 200 UB 18.2. In here also the thickness shall be less than 11 only. So we can left click on OK. We can just save this model first. Now we can save this model, and then after that the important parameter again that we do need to check is that we do need to add the angle sections and channel sections. Now if we're talking about the angle sections, so in that case we can select steel angle here and then left click on OK. And as per the Australian standard New Zealand library, we can opt for thickness less than 11 because most of the angles section sizes that are usually used thickness is less than 11 mm. So we can, the section that I usually use is 75 by 6, and after that I do select 65 by 65 by 6, and then after that I select 50 by 50 by 6. Why I am opting for 6 mm minimum is that we do need to provide minimum of, we can say, 6 mm thickness. So although it is recommended that for 6 mm welding, it is required that we can proceed with 8. So instead of 6, we can proceed with 8. So 65 by 65 by 8 and 75 by 75 by 8. Now 100 by 100 by 8 can be used, but that is like used where the wind loading is like quite high. The axial loads and the pipe rack push and pull loads or thermal loads of the pipe rack, that is also quite high. So we can proceed with these 4 angle sections as of now. After that, again, we have already selected the correct material properties here, and in here we have selected thickness less than 11 mm because our thickness is we can say 7.8 itself. So that is also okay. And after that, again, we can left click on import new properties and we can add C channel sections. Now C channel may be used when we are talking about the vertical bracing. So in the plan bracing or in the horizontal bracing along the pipe rack floor itself, we can provide the, we can say, angle sections. But if we are talking about the vertical bracing, it is usually done with the help of this chassis channels itself or parallel flange channels here. So usually I do proceed with 100, 150, 200. 250 is like quite heavy section, so we can proceed with OK here, and then left click on OK again. So now we have selected all the correct, we can say, or desirable section properties. So now in the next lecture we shall start making the model of the pipe rack.